All right, working in this unit, Extrema on an interval. We're going to talk about different parts of a graph. Now, the nice thing for you is in your algebra classes, you've graphed polynomial functions, you've graphed rational functions, you've graphed trig functions and trigonometry. You've seen a lot of the graphs before. What we're going to be talking about are some different aspects of the graph without actually drawing them, okay, for that piece. That being said, this next test, you will not be allowed to use your graphing calculator. Because if you could look at the picture, you'd have the answer instantly. Okay? That being said, throughout this unit, think about how to do something without it. It doesn't mean you won't need it at all on a homework problem or something like that, or get some complicated decimals, stuff like that. I'm not saying that's not going to happen. That will happen. What happens on the test is just make the numbers work out really nice. You don't need that. Okay, I do have a few scientific calculators you can borrow if you really feel the need. You need that security come test time. It's just the graphing piece you won't have. Right? Extreme values on an interval are things that you've seen before. If I just draw some random graph here, we would say that this is what we call a relative max. It's also called a local max. So, depending on what your teacher called it before, we call them relatives or locals. This book mainly calls them relatives. It means the same thing. Down here would be a relative min. You get a low point there. You can actually have multiple relative maxes or mins. So, get another one here. So here you'd have a relative max, a relative max, relative max. And then down here you'd have a couple of mins. And relative or local just means in that region. Okay, so if you were to look at the mountain range, well, there's all types of maxes. Okay, all these little peaks out there. Now, if you were looking in a specific window, yes, there'd be one peak that was taller than any of the others. We'd call that the absolute max. It'd be the tallest. Okay, but there'd still be other relative ones. Okay, same with the minimums. All the little valleys in between the peaks would create a minimum. Okay, for that piece. That's all we're talking mean by relative to that location. Okay. Absolute maxes and mins would refer more to the highest or lowest point. So in the first graph, there is no absolute max nor an absolute min. As the arrows on the end say it's going forever, right? So this thing just keeps going down. This guy just keeps going up. However, on this graph, this would be an absolute min. And that just means the lowest possible point. There is a dot there. It's not an arrow. It doesn't keep going. And it also has an absolute max. That relative max in the middle is also the absolute max. Now, graphically, when you just look at the pictures, that should make sense there. Oh yeah, see the high point, low point. Yeah, I can tell that point's higher or lower than every other point on the graph. Pretty simple looking at it. Now let's take it back to what we've talked about before. To us, what's the derivative? Slope of the tangent line. Look at each of those relative maxes and mins. What would the slope of the tangent line be? 0. So the slope of the tangent line is 0 at a max or a min, relative max or min. Picture horizontal tangent sitting in there. Before or after that horizontal tangent, the slope's either positive or negative. Everybody okay with that? Yeah. Mm-hmm. All right. All right, so if the tangent line slope of the tangent line is 0, that means you may have a relative min or a max. That would also be called a critical number. So up here I've got the definition of a critical number. Some critical number, C. Okay, so for some x value, C, if the derivative at C is 0, or if the derivative does not exist, that means C is a critical number of the graph. Now we're just going to be talking about some maxes and mins today. A critical number is where a number of things could happen on the graph. Right? You could have maxes, mins. Other things would be where the graph splits, like a piecewise function, or you could have a vertical asymptote, you have a domain restriction, something like that. Something's going on there, so we call it a critical number. So these are the ones where one may exist for what we're talking about. As far as the derivative not existing, here is a min where the derivative does not exist. If I had an absolute value, I think you would agree that that is a relative min. It's also an absolute min. It is the lowest point. Okay. That being said, though, the derivative doesn't exist there. The derivative is a limit function. So this has a constant negative slope, constant positive slope. They don't approach 0. So that derivative does not exist at that point, but it still is a minimum. Are you okay with that?
Yeah.
And that's different than the parabola.
So if there was a question that asked for all of the relative mins or all of the relative maxes, would you put the absolute max into that?
Yes.
Okay.
Right? You would. Now, as far as the absolute is concerned, the absolute, we need to know what the y values are. So obviously the slope of the tangent line is not 0 here. And the reason it's not is because, remember, the derivative is a limit function. So you'd have to have both sides coming into the point. There is no left side of this point. So I really don't know the value of derivative there. But if I compute the y values, so we think about points on a graph, I have 1, 2, 3, 4, 5, 6, 7 x values that are known, where it's 0 or an endpoint. Well, if I put those 7 x values into the function and generate a y value, one of those y values is going to be the lowest y value, and one of them is going to be the highest y value. And it would show up as these two. Does that make sense to everyone?
Yeah.
Those are just points on the graph for that piece. Now, the nice thing for you, okay, you know how to find the derivative. That's not new. You don't have any new rules right now. Power, product, quotient, trig, chain still involved. Same derivative rules. You know how to find a derivative. We set that equal to 0. We've seen in the past that sometimes that's really easy, and there have been a couple of times we've had a little bit of trouble solving that equal to 0. That's just going to happen to us. But we know how to solve an equation. So I can figure out where the derivative equals 0, and I can figure out where the derivative doesn't exist. As far as 0 versus doesn't exist, here's a nice simple one. If I said f prime of x is 2x minus 1, and I set that equal to 0, I have x as a half. Nice, simple solution. Everybody agree?
Yeah.
Yep. Right, so critical number would be at a half. That's where that derivative value equals 0. Well, let's say the derivative is x minus 4 over x plus 2. Well, now I would have critical numbers at -2 and 4. -2 because it doesn't exist at -2. There's that domain restriction. By saying the derivative doesn't exist, we're referring to a domain restriction. You know about that. If I said, well, where does this fraction equal 0? Remember, if a fraction equals 0, it just means we can set the numerator equal to 0. That's where I'm getting that 4. So it's, again, stuff you've seen for that piece. Now let's mix this into some actual functions here. So we're going to find the critical numbers, whatever they may be, So to find the critical numbers, we need the derivative, right? So we're going to take a look at the derivative. We're going to determine whether the derivative is 0 or where it is 0 or where it is undefined. And then that gives us x values to see if we found an extreme value. Right? So I'm going to say find the extrema. And when it's written like this is referring to the absolute max or min. Right? It doesn't say relative extrema. Find the extreme, the highest, the lowest. So here's my function. F of x is x to the 4th minus 2x squared plus 3 on -1, 2. There's my interval. So I've got this 4th degree polynomial. I don't want the entire 4th degree polynomial. I just want to look between -1 and 2. That's all I'm concerned about. And I'm trying to find the highest and lowest point or value in that interval. So the first thing I need is that derivative. I'm going to check for critical numbers.
What's the -1?
Is it good?
I think so.
The -1, that's just the interval.
Oh. Why did it say borderline?
On.
Oh, sorry. Okay.
No,
Sorry.
that's my writing. All right, 4x cubed minus 4x. Everybody agree with that derivative? Yep. All right, so I need to look for where that derivative equals 0 or where it's undefined. Well, this derivative is not undefined anywhere. I don't see any division or anything like that. Okay, I don't have to worry about that part. So I'm looking where it's equal to 0. Let's see, I could take a 4x out. That leaves me x squared minus 1 is 0. So that gives me critical numbers at 0, 1, and -1. 0, 1, and -1. Everybody okay with those three values?
Yeah.
All right, now I want to find out which one of those x values produces the lowest y value, smallest y value, and the largest y value. So I'm going to go test them. I'm going to find f of 0, f of 1, f of -1, and I'm also going to find f of 2. All right, so 0, 1, and -1, those are my critical numbers. Those are the ones that were eligible to be that highest or lowest value because that's where it's possible to have those relative mins or maxes. The endpoints are also eligible. You've got a graph that stops. So for example, this is not the graph, but I've had something like this, hey, that's going to be the highest. That will not be the lowest, this will. So if I have an interval, I've got to check the endpoints. The endpoints would be eligible. So I check each of the values. Now we're talking about the original graph. So I'm going to put each of these values or substitute them into the original function. So f of 0 is 3. F of 1 is 2, right?
Yeah.
2. F of -1, also 2. And f of 2, let's see, what's that? 16 minus 8, 11? Yep.
Oh, there's so small.
So this would be the max. So we would say it has a max value of 11 at x equals 2. Remember, the y value is the highest value, so this will be the max value, 11. And then we actually have 2 mins. So yes, we can have multiple mins or maxes. So there are 2 absolute mins because it reaches that lowest y value of 2 in 2 spots. Are you okay there?
When we do questions like this, are we only looking at whole numbers?
No, you would be looking at only where it equals 0.
Okay.
So it's those critical values. Whether or not they'd be whole numbers or fractions depends on what those critical values are. But I'm only looking at the critical values, and I'm only looking at the endpoints because they're the only things eligible. Because remember that min or max is where the slope of the tangent line is 0, so that's eligible to be the highest or lowest. So would an endpoint.
Okay.
It's for what those values are. Look at this one. Let's go f of x equals 2x minus 3x to the 2/3 on -1, 3. So I've got my endpoints, the -1 and the 3. I just need the derivative to see what produces out of the critical numbers there. Let's see, 2 minus, that would be 2x to -1/3. Everybody agree with that? Okay, so I got my derivative function. I'm thinking about where's my derivative function, undefined and or equal to 0. Okay? So this is correct. If you're not a fan of negative exponents, then you can move it to the bottom. Make that 2 over the cube root of x. But either way, I've got to figure this out. So I do have one value where the derivative is undefined at 0. Everybody agree with that? So if you look at that function right there, the domain restriction would be 0. So I do have a critical number at 0, undefined. So now I'm going to take a look at what happens when I set this equal to 0 and solve. Let's see, I can move that over. 2 equals 2 over the cube root of x. Multiply both sides by that cube root of x. Let's see, that would give me, write that back up there in a second. 2 cube root x equals 2, which means cube root x is 1. And that would mean x is 1. So my critical numbers are the 0 and the 1. 0, I had it there a minute ago. And then now my 1 from solving it when it's equal to 0. So remember, we get rid of the cube root, we cube. Cube 1, you still get 1. Are they okay there? All right, so how many values am I going to test total?
4.
4, good. Because I've got the 0 and 1. We're going to check the 0, the 1, but then we also need to check the 2 endpoints because they are eligible to be the highest and lowest point also. So into my original function here, f of 0, that's 0. F of 1, let's see, that would be -1.
Yes.
F of -1, -5. Agree with that one?
Yeah.
F of 3, I don't know. 6 minus 3 times the cube root of 9. And you know what? Yes, I can go get a decimal in my calculator, but this is sufficient also. Okay, I'm not saying you'll never need a decimal. What I said as far as your test is concerned, since you can't have your graphing calculator, it either wouldn't work out to a decimal or it would be kind of obvious. So let's kind of look at this in this raw form. Now, you probably don't know what the cube root of 9 is. I don't either. I know it's bigger than 2. Because the cube root of 8 is 2. So I know it's 2 point something. Everybody okay with that?
Yeah.
A little bit bigger than 2. Probably, I don't know, 2.1. I have no idea, but I know it's a little bigger than 2. So you take something a little bit bigger than 2, and you multiply it by a 3, you're a little bit bigger than 6. Everybody agree with that? You take 6 minus something a little bigger than 6, that's negative. Everybody agree? Is it negative 5? No, so that's going to make this the min. And that makes the 0 the max. So even sometimes if you don't get a value like you like, yes, you could go get a decimal for that, but also you need to work on the idea of being able to think through what the value is. I didn't need to know exactly what it is, okay? But I know it's not negative 5, and I know it's negative, so that makes 0 the max. Everybody okay with that? That's how you can work through some numbers. Now, that might not be the case. I might really need a decimal if this was like not 0, but maybe negative 0.2. All right, now I might need a decimal for this. Okay. Something like that. All right, you try this one. Let's see what you come up with. Let's go. F of x, 5 plus 10x minus x squared on, let's go on negative 3 to 3. We got to check for a critical number. We know we got to deal with the negative 3 and the 3. Let's figure out the critical number first. Hey, let's see how you're doing so far. I know you're not finished, but did you at least get a critical number of 5?
Yeah.
Everybody agree critical number 5? All right. And I'm going to throw that guy out. I don't want it.
Oh, because
It's not in the interval. All right. So what we found is 5 is a critical number. And yes, 5 is a critical number of that graph. No doubt there. But I'm not looking at the entire graph. I'm only looking at between negative 3 and 3. So that's why I'm not going to worry about 5. Right? I'm not saying it's not a critical number of the function. I'm saying it's not a critical number in the interval of my function. So I will not check that one. I will only worry about checking the negative 3 and the 3. My 2 pieces. So as far as determining a min or a max, I would only check the negative 3 or the 3. And let's see. What's negative 3?
Negative 34.
Negative 34? Yeah. Negative 34. And 3.
I got negative 16. Because it's 5 minus 30.
So that's
plus
negative
9.
25 minus 9.
Okay.
Because you're going to square the negative.
That makes sense. Sorry.
26?
Yeah.
Right? Okay. So, pretty obvious there. There's my max. There's my min. Negative 34 smaller than 26. Everybody okay with that? Right. Now, if I had not been given the interval of the negative 3 to 3, then the only thing I would check is the 5. Okay? That was a critical number of the graph. I just don't have any endpoints to worry about. Everyone okay with that? All right. Well, let's take a look at your assignment.